Question number 3, we were going to use the chain rule to find the derivative of both of these two functions here. Now this one's much easier to see as you write it like this over here. So really what we've got going on is 3x to the negative 1/2 power, okay, or 3u to the negative 1/2 power, and then our u is our 2x plus 1. So thinking of this as outside-inside rule, we've got dy dx being equal to, we've got 3u to the negative 1/2. So that would be 3 times negative 1/2 u, which is our 2x plus 1, to the negative 1/2 minus 1, times then the derivative of the inside. The derivative of 2x plus 1 is just simply going to be 2. Okay. So simplifying this down, then we get dy dx is equal to negative 1/2 of 2 would be negative 1, times 3 would be negative 3, times 2x plus 1. Negative 1/2 minus 1 more would be a negative 3/2. Okay, so that right there would be an acceptable answer. There's also other ways to express this. We could also say negative 3. The 2x plus 1 is raised to a negative power, so that moves it to the denominator. And then this is taking the square root of a cube. So we could say this right here, to the third power. We could also say negative 3 over 2x plus 1 to the positive 3/2. Anything equivalent to that would suffice for part A. For part B, though, we have a 3-link chain. We really want to recognize B as being this. Y equals the sine of 3x minus 2, and then that whole quantity is being squared. So the most important thing going on here with this composite function is the squaring. And then what are we squaring? We're squaring a sine. Sine of what? The sine of 3x minus 2. So this is a 3-link chain. The outside part is the x squared. So our derivative of a square is going to be 2 times of that quantity to the 2 minus 1. And that quantity right now happens to be the sine of 3x minus 2. Okay, so there's the derivative of the outside evaluated at the inside, times the derivative of the inside. Well, the inside is still a chain. The outside part now is the sine. The derivative of the sine is cosine, still evaluated at the 3x minus 2. And now finally times the derivative of the inside, the far inside. The derivative of 3x minus 2 is 3. So our derivative, as we simplify this down, dy dx, we've got constants of 3 and 2. 3 times 2 is going to give us 6. Sine of 3x minus 2 to the 2 minus 1 would be to the first, so sine of 3x minus 2 cosine of 3x minus 2. Okay. So on question number 3 then part A was just 2 links in the chain. It was an outside and an inside, but B had 3 links to the chain. We had a square, we had a trig function, and then we had just a basic polynomial function on the inside. So that was a 3-link chain on that one.